Hi there grade 8s and welcome to WorksheetCloud Maths. If you're joining us for the very first time today, a very big warm welcome to you, and I hope you are going to enjoy this lesson so much that you are going to continue to watch our lessons. For those of you that have been with us for a long time, I hope you will enjoy this lesson and I hope you are keeping well and you are looking forward to what's to come in this lesson. Right. We're going to be doing lesson 6 in measurement, but remember, if you haven't watched the other lessons, you're more than welcome to go and watch them. Otherwise, this is a standalone lesson, and let's see what is waiting for us. So today we're going to be looking at how to calculate the area of a circle. Now remember, the area of a circle with the radius, so the area is A of a circle with the radius R, is given as A is equal to pi r squared. Now remember, the area of a shape is the amount of space that is covered within the sides of the shape. So within the closed sides of the shape. And with the circle, remember, it's not the sides but the circumference of the circle. So to work out area, it is pi r squared. But how do we get pi r squared? Okay, let's have a look at this. Okay, we can show this formula as A equals pi r squared by dividing the circle into sectors and then place the sectors so they look like a rectangle, something like that. So there you can see the circles with sectors, okay, different sections of the circle. We almost cut it and then fold it out so that it looks like a rectangle. And if you have a look there, you can cut down that part and add that to there, and then it will look like a rectangle. Okay, so the number of wedges grows. As the number of wedges grows, the edges become less bumpy. So as you get it becomes straighter and straighter, and the sides become more vertical. So again, like I said, you can cut this side and take that and put it on the other side, and actually then it starts looking like a rectangle. And we know how to work out the area of a rectangle. It's length times breadth. If you have a look here, that would be half the circumference, okay, because the other half is on the other side. So what we've actually done is taken all those bits, like the yellowy green bits, put them all together on the one side and put the gray bits in between. So we've got half the circle here, like that. So that is half the circumference. This is the other half of the circumference. So actually your length is half the circumference, okay. So A is of the area of the rectangle, is L times B, right? So if L is half 2 pi r, because remember, circumference of a circle is 2 pi r. So L, the length, as you can see there, the length is half of 2 pi r times the radius, because the radius would be that, okay, as where I'm pointing to now, from your circumference to the middle point. So here it would be that. All right, everybody understand? So then your area of the rectangle is half your circumference times by your radius. Okay, so it's half times 2 pi r times r. And half times 2 is 1. So you're going to end up with pi r squared, because the half cancels out the 2. You got pi r times r, which gives us pi r squared. So there you can reason out why we are using pi r squared. Let's just go over it one more time. You cut the circle, okay, you divide it into sectors, you cut them out, you then stretch them out and put them so that your one lot goes one way, and then you fit the other lot into the other side. So it would be a good thing for you to try this at home and see if it works out. And put your sectors or color your sectors in two different colors, alternating colors. You will then see when you cut them out, you can put all the one color standing up, pointing up, and the other color will fit in going the other way. All right, so that it ends up being more or less like a rectangle. So you know that to find the area of a rectangle is length times breadth. You also know that doing it this way, that is half the circumference of the circle, and circumference we work out by saying 2 pi r. All right, so half of the circumference, half times 2 pi r, times by the radius, which is actually your breadth of your rectangle. All right, cancel that all out. So the half cancels out the 2, and you end up with pi r times r, which is then pi r squared. Guys, I really encourage you to go and do this so that you have a deeper understanding of actually why we got to that formula for the area of a circle. Okay, because actually, if we look at our area of a rectangle, it's all the area in between the sides. Okay, same with the circle, so it's all these areas added together. Okay, right. Also, another way to remember pi r squared and 2 pi r is because area is always measured in units squared. So that's why that little square gives it away. When it's pi r squared, it would be for the area. When there's no square, which means it's 2 pi r, that is for the circumference. Right, let's have a look. Okay, so let's put this knowledge into practice. Find the area of a circle with a radius of 30 millimeters. Okay, you don't need to see it, but if you really want to draw a diagram, you definitely can. Draw your circle with a radius of 30 millimeters and see how to work out the area of that circle. So we know that the formula is pi r squared for area. So there it is, area is equal to pi r squared. Remember, pi is 3,14. So it's 3,14 times our 30 squared. Okay, it's 30 times 30. So that would be 3,14 times 900 millimeters. Again, if you can't work that out on a piece of paper, you are definitely able to use your calculator for this. So 30 times 30 will give me 900, but it's not just millimeters, remember, it's millimeters squared, right? So 3,14 times 900 millimeters squared is going to give me 2,826 millimeters squared. Everybody happy? Remember how we got our formula? By using the example that we used just now of changing a circle into a rectangle by dividing it in sectors. So you do understand the formula. You then substitute into the formula because we know that pi is 3,14 and our r, our radius in this case, was 30 millimeters. Take a 3,14, well, first of all, take your radius, square it. So it's radius times radius. It's going to give me 900 millimeters squared, and then we're going to multiply that by 3,14. We end up with an answer of 2,826 millimeters squared. Please do not forget that little square, that little exponent. It is so important. Okay, right. See if you can complete this table. Okay, here we have a table. Area is left out in each one. We've got the radius in 2 of them and the diameter in 1 of them. But let's look at number 1 first. If we've got a radius of 5 meters, let's fill in the diameter first, and then we'll go back and work out the area. So if we've got a radius of 5 meters, we double that to get the diameter. So our diameter in this case would be 10 meters. Okay, let's work out the area. We know that our formula for area is pi r squared. We are then going to substitute into that. We know that the constant, the pi, is 3,14, the value of that, 3,14. Then we're going to go back to our radius. We're going to take that and we're going to square that. We all should know what 5 squared is. It's 25. So it's 3,14 times 25 meters squared. And use your calculator to say 3,14 times 25, and you should get 78,5 meters squared. Okay, we then put that back into our table to complete our first line. Right, now for the second one, I'd really love it if you could pause the video and you try and work out the second one and the third one on your own. And when we come back, we'll go over it together. When you come back, we'll go over it together. So pause the video now and try and work that out on your own. Right, let's see how you did. Okay, so first of all, we've got the diameter. We want to halve that to get the radius. What is half of 28? It is 14. Okay, we now have the radius. We can now work with that to work out the area. remember our area remains the same, the formula remains the same as we've been using. So area is equal to pi r squared. We then substitute in, we end up with 3,14 times 14 meters all squared. Remember 14 times 14 you can work out on your calculator. So you're going to go 3,14 times the 14 squared, and 14 squared is 196 meters squared. You then multiply that by pi, and you're going to end up with 615,44 meters squared. Once again, just a reminder not to forget your exponent. If you do, then it is not a measurement for area, because it will be a straight measurement. Okay, so we plug that back in to our table, and we've completed our second row. Were you all able to do that? I'm sure you were. If you weren't, remember, if you've got a question or a query, to please email grade8@worksheetcloud.com, or you can go back and watch the video from the beginning, and it will explain to you exactly what to do. And guys, please don't be afraid to use those calculators with these bigger numbers. It's just much easier and much more time, or much less time consuming than working it out on a piece of paper. But if you don't have a calculator, obviously you must feel free to work it out on a piece of paper rather than trying to calculate that in your head. Right, let's get on to the last one and see how you did with this one. We've got a radius of 7 meters. What is the diameter? Well, all we have to do is double it. So 7 meters times 2 is going to give me 14 meters. But that's just for this table to fill in what was left out. We don't need that to work out the area. We only need the radius, and we were given that as being 7 meters. So let's plug that into our formula. Pi, remember, is 3,14. The radius is 7 meters, and you have to square that. So it's 7 meters all squared, which gives us 49 meters squared. Times that by 3,14, and we end up with an answer of 153,86 meters squared. Take that and plug it back into your table, and we have now completed the last line of the table. How did you do, guys? I'm sure you did very well. Remember, if there's anything you're confused about and you need further explanation, to send your email into grade8@worksheetcloud.com, or to go and watch the video from the beginning. Right, can you work out the area of this shape? Let's have a look. Right, there we go. There is a semicircle at the top of a rectangle. So if we were to work out this shape, we would have to work out both areas independently and then add them together. We are told that the length of the rectangle is 30 millimeters and the breadth is 20 millimeters. So if the breadth is 20 millimeters, that would give us our diameter, right? So we've got the diameter, easy to work out the radius, but let's see how to do it. So if we have to calculate the area of this shape, we're going to first of all find out the area of the semicircle plus the area of the rectangle. So the area of the semicircle will obviously be area of a circle and halved, all right? So we're going to go half pi r squared plus length times breadth. So our the r, the radius, remember, because the diameter was 20, the radius would be 10. We have to square that, then we're going to multiply it by 3,14, and then we're going to halve it. Alternatively, what we can do is halve 3,14 and then multiply it by 10, or by actually 10 squared, which is 100. But the rectangle is easy because it's 30 multiplied by 20. Okay, so let's start working this out. Half times 3,14 is 1,57. 10 millimeters squared gives me 100 millimeters squared. 30 times 20 gives me 600 millimeters squared. So all in one step, basically, we've worked out the area of the rectangle. Let's carry on, and we can work out the area of the semicircle, and that would be 157 millimeters squared plus the 600 millimeters squared. We end up with 757 millimeters squared for that irregular shape. Can you see? When you've got an irregular shape, you have to look at what it's made up of. And here we saw that it's made up of a semicircle and a rectangle. Okay, so then we work out the area of a circle and halve it. We work out the area of the rectangle and add them together. Okay, try this one on your own. It's going to be, might be a bit of a challenge, but when we come back, you'll be able to see what to do. Okay, so we want to work out the area of this entire shape. I want you to pause the video, and when you work it out, remember to divide it up into shapes that you know. Okay, pause the video. When we come back, we'll go over it together, but you try and do it all on your own on a piece of paper. Right, let's see how you did. Okay, so the first thing I would do is divide our areas up and name them. So it's easy to refer to, because quite a lot of working out to do here. We've got this area, we've got that area, that area, that area, and then we have to add them all together. Okay, and there even might be a measurement that we need that we don't have. So let's take P first. Sorry about that. That's how did you do? Let's see how you did. Okay, so we're going to take P first, and it's going to be length times breadth. Okay, what's the length? It's 16 times the breadth is 12. Now here, guys, we're not given whether it's millimeters, centimeters, meters. We don't know the unit, so we'll just work with the numbers, and we can say units squared if we want to at the end. All right, so L times B is 12 times 16. That's going to give me 192. Okay, we don't have a unit to put in, so it's just 192. Now we're going to work with the area of Q, because it's also pretty similar. In fact, the measurements are the same. So here it's also 12 times 16. Again, it is going to give us 192. Then we can work out the area of R, which is a right angled triangle. See, when these two sides of the rectangles meet, it's going to form a right angle, so we can say that is a right angle triangle. But we know now what the height is. It's 12, and the base is 16. So what is our area of a triangle? It's half base times height. Okay, so we're drawing on prior knowledge here to work out the area of the rectangle, and also working with the area of a triangle. So it's half base times height will be half times 16. 16 is the base, times the height, which is 12. Half times 16 will give me 8, and 8 times 12 we will work out now. Or you can go 16 times 12 gives me 192, and half of 192 is 96. So as you know, 8 times 12 is 96. It's just a double check. Right, now what are we going to have to do? Okay, so we've got this area, we've got that area and that area. We need this area. But this is the side that we don't have the measurement for. But we do know that this is a right angle triangle. So in order to work out that, we can use the theorem of Pythagoras. Okay, so we need to find out the diameter of S. So the diameter of S is actually the hypotenuse. Okay, did you all see that? That's the hypotenuse of this triangle. So if we use Pythagoras, we're going to go the hypotenuse squared is equal to the sum of the other two sides each squared. Okay, so here we've got the breadth of the of R. It's not really, it's the base, sorry, of R, and the height of R. Okay, so the base of R and the height of R, which we know the base is 16 and the height is 12. We have to square those, and then we're going to get the square of the hypotenuse. So let's just plug it in there. Okay, we're going to end up with 16 squared plus 12 squared, and that's going to give us our diameter of the half circle. But remember, that is the hypotenuse, so it would be squared. We would then have to square root it to work back. So let's say 16 squared is 256, 12 squared is 144. Add those together, we end up with 400. Okay, that is the hypotenuse squared, which happens to be the diameter of our circle. All right, we now have to square root that to get the diameter, and so the diameter of the circle is 20. So the circle we've labeled S, the diameter of S is 20. We can now work out what the area of the circle is, but now we want half of that. So our area of S is going to be pi r squared, and pi is 3,14 as we know. R is half of the 20, so it will be 10. So we're going to go 3,14 times 10 squared, and that's going to give me 3,14 times 100, and that gives me 314. But now remember, I've got to work with half of that. But how are we going to work out the area of everything? We're going to add everything together. So there's a lot of working, and we haven't even got to the area of the whole shape yet. Okay? So what I'm trying to say to you is don't be afraid to do a lot of working out to come to the area of an irregular shape like this. So we're going to go, the area of the shape is the area of P, the area of Q, and the area of R, plus the area of S. Now remember, we can say area of S because it is actually, that is that shape, but it is a semicircle. Now just before we carry on, I just need to check something for us. Right, let's carry on. So we've got the area of P being 192, the area of Q being 192, the area of R being 96, and we worked out the area of S, but remember this is the whole circle, being 314, and here our area of this S is going to have to be half of that. So we would then have to go 192 from there, 100 plus 192 from there, plus our 96 from this area, plus 157 because it's half of this. Okay, don't forget to halve it because it's only the semicircle that we need the area for. If we add those all together, we're going to end up with 637. So that is the area of the whole shape. If we were given the units of measurement as say being millimeters, then it would be 637 millimeters squared. But in this case, we weren't given any units, but just remember it would be the square units if there were units there. Okay, guys, so that was quite a lot of working just to work out the area of one shape because the shape is an irregular shape. When we've got a regular shape, it's so much easier to work with. So if we've got just a rectangle, easy peasy. If we've got just a triangle, that's also easy. If we've got just a circle, that also becomes easy now because now we know what the formula for that is. But when we've got a whole lot of shapes put together, we're going to have to add them all together to get our final answer. Okay, I'm sure you're going to be able to do anything, any kind of shape, as long as it's made up of regular polygons. Right, that's all for today. I hope you enjoy watching that and watching this lesson. And please don't forget to do the activity that is attached to this lesson, and you can always check it against the memo that is also attached. I really hope you join us again. I've so enjoyed teaching this lesson to you. I hope you've enjoyed it just as much. Okay, and I hope you find some of the things a little challenging, the same as in your activity. Please remember to join us again for our next lesson. Thank you for now and keep warm.